Okay, part two of this particular module, we're going to look at other lines on the Skew T chart. There are a lot of them. In part one, we talked about the isotherms and the pressure levels. Now we're going to talk about lines such as what we call dry adiabats. These are these yellow lines on this particular chart. And then pseudo-adiabats, or the moist adiabats. You can think of that as the moist adiabats. In this particular chart, it's the purple line. Now, in many different charts, the line colors will be different, so don't get caught up on the line colors. The dry adiabats are these that go from lower right to upper left. And then the moist adiabats also do that, but they have a little bit more of a curve to them. Why do we care about dry adiabats and moist adiabats? Well, we've been talking about air parcels in the chapter on stability. And simply, if the air parcel, which is just a single piece of air, is warmer than the surrounding environmental temperature, then it will want to rise. And as we know, rising air, eventually it cools to the saturation vapor pressure curve. When it reaches this curve, it goes from gas to liquid water, and we have the production of a cloud, like what we saw in mountain simulation. So if an air parcel is dry, in other words, it hasn't reached the saturation vapor pressure curve, the air parcel will go up in the atmosphere, but it will follow these dry adiabats. Let me see if I can get in here a little bit closer to illustrate this point. So if I had an air parcel sitting on this dry adiabat and it began to move upward, it would follow parallel to this dry adiabat. Now, once it became saturated, in other words, it reached the saturation vapor pressure curve, it will no longer follow the dry adiabat. It will follow the moist adiabat, or what we call a pseudo-adiabat. Now, the moist adiabat are these curved purple lines. See, I've got these curved purple lines in several different areas. You can see that there. And they become more steeply curved as we go further to the right. Well, let's say we had a dry air parcel and it was moving up, as you see with the crosshairs, and all of a sudden it became moist. In other words, it went from water vapor to liquid. It would now follow on the path of the moist adiabat. Keep in mind, it would not continue up the dry adiabat, but it would go up the moist adiabat. Notice its temperature is changing, but not as much. So the thing to remember about this module, if the air parcel is dry, it will go up the moist adiabat. If it is moist, it will then go up the moist adiabat. And you'll see why we look at this here in a few minutes. Now, in the remaining minute that I have here, I'm trying to keep each of these modules to about 5 minutes. I would like to talk about a couple of more lines. This red line here that you see is the environmental temperature. That's the temperature measured by the balloon. You remember in radiation sim, you had a balloon and you moved it up through the atmosphere and we measured temperatures. Well, it's the same thing. When the National Weather Service launches a weather balloon, it has an instrument in there that measures the temperature, dew point temperature, wind speeds, wind direction, relative humidity. But this particular line, the red one, is the temperature of the atmosphere as we go up. So if we were to look at the surface here, it looks like the surface temperature is halfway between 10 and 20. So this would be about 15 or 14 degrees Celsius. Now keep in mind the temperature of the air parcel is different from the temperature of the environmental atmosphere. We'll pick up with this in part 3.